Okay, so here we are on 10.4 notes, ellipses. And so what we want to do here is we want to go ahead and practice classifying, um, um, these kind of equations for our conics. So for this one, first one, we have an ellipse. Ellipse has three different things. So first of all, it's squared variables. It has the same sign. Both of these variables coefficients are positive, but different coefficients. Number two, a circle. We have squared variables, and each of these have the same coefficient. Okay. Number three, another ellipse. Again, squared variables, same sign, but these coefficients are different. We have a 1 and a 4. Next one's a parabola. Okay, one squared variable. Number 5, we have a hyperbola. Again, squared variables, but this time the signs are different, a positive and a negative. Next one, not even a conic, it's a line. How do we know it's a line? We have x to the first power. There are no squared variables at all. Last one we have here is a hyperbola. Again, squared variables, hyperbola, but different signs. One's positive, one negative. Okay, so let's go to the standard form. Standard form is a lot like your circle, but just slightly different. So with our ellipses, our standard form is going to be x minus h, quantity squared over a squared plus, okay, y minus k squared over b squared equals 1. Now this right here will always be 1. Okay, so this one right here will always be 1. No matter what, you want that to always be 1. You're slightly different than the circle. Well, not slightly different, it is different, okay? And so let's talk about each of the parts that we have here. The center is the same. So the center is dealing with the same idea as before. So our center, it looks like, write that. Our center is going to be our HK. Again, same thing with our circle. This one will go left, right. It's always the opposite. And this one will go up, down. Again, it's the opposite. What do you think? So if it's minus k, then that means we're going to go up. Positive k, we're going to go down. Okay, so to look at an ellipse, obviously if you see ellipses, it looks like like an oval. People like to call it an oval. So there is some kind of center and some kind of radius going off. So the horizontal radius, I'm going to quotes around it because it's not, is the A, okay? And then the vertical radius is the B, okay? So let's use that idea and to graph our circles, our ellipses. Okay, so let me move this up. Okay, so our first one we have here, we have our center will be, we're going to go this way 2 and up, down 1. Okay, so that means our center is going to be at 2, -1. The horizontal radius, okay? So that's the A, all right? So that is going to be the square root of 9, so that's going to be a 3. And the vertical radius, square root of 4, is going to be a 2. Okay, so we're going to graph it just like we do. Anything else? So we're going to plot our center first. 1, 2. And we're down here at -1. Okay, so the horizontal and the vertical. Okay, so let's do the horizontal first. And so we'll go over 1, 2, 3, 2, 3. vertical is up 2 and then down 2. Again, try and make your circle here, or not your circle, gosh, sorry, I keep calling it circle, your ellipse to be kind of flattened out here. It's not, not like a football or anything. Sometimes we have a tendency to draw like a football because it's harder to get around these little. Okay, so again, I have points here and here. Okay, so this way was 3, but this way was 2. Okay, so let's go to the next one. The next one we have our center at. Again, this is going this way, and this is going this way. So we have a -3 and a 2. We have a horizontal, so it's not there, but it's understood 1. So we take the square root of 1, we get a 1. And a vertical radius is square root of 3, which is, square root of 9, which is 3. So I'm going to plot my center. 1, 2, 3, 1, 2. And then my horizontal is just going to go over 1. But my vertical is up and down 3. 1, 2, 3. 1, 2, 3. This is kind of look like a squished kind of thing here. Again, this way is 3, but this way is a 1. So it's kind of squished in there, okay? So think about that, how that length is. So if that's 2, then that has to be 2. But this has to be 3 going this way. So kind of almost like your circle in a sense on the distance, but the distance between here and here, the length of that's going to be, is not equal to the length of this. So, okay, so let's go to the next page. And we're going to go to what happens if it's not in standard form. So the same things apply as it has been. Okay, if it's not in standard form, then we are going to have to complete the square again for x and y. So complete the square for x and y. Okay, same thing. We're going to group together. So we're going to put x's together and our y's together. So I'm going to move things around. So I have an x here and x here. So I will do 25x squared plus 100x. And then I'm going to put my y's together. And we already have a -4 over there, so we're good. So it's already moved over. But each of these, I need to factor out an a. So let's factor out an a. So we get 25's got to factor out. So we get x squared. 100 divided by 25 is a 4. So if I were to complete the square on this one, I would get 4 divided by 2 is 2, 2 squared, so I would get a 4 here. Okay. Now to add that to the other side, though, I have 25 times 4. So this over there has to be plus 100. So don't forget to add those together. Plus 100. Okay. And then now we have to factor out a 4. So we get y squared minus 4y, 2y. Plus, and then so now, if I complete the square over here, I'm going to have a 1, but 1 times 4, I'm going to add a 4 and put underneath here. So those 4's cancel, so I wind up with just a 100. So I'm going to just kind of clean this up. So this is quantity squared, x plus 2 plus 4, and then we have y minus 1 quantity squared, and that has to equal 100. Now again, this right here must always equal a 1. So that means in order to make it a 1, I have to divide everything by 100, okay? So again, that doesn't look like the word must. That must equal 1. Just going to put a little note there. So if I divide everything by 100. Okay, so remember our formula is kind of a fractured, it's a fraction, so we want to kind of make sure that that looks like, but all these A's are reduced, okay? So reduce everything, 25 over 100 reduces to x plus 2 quantity squared over 25 over 100 reduces to a 4, plus 4 over 100 reduces to 25, so that's y minus 1 quantity squared over 25, and then 100 divided by 100 is 1. So now we're in the form that we need. We know our center is now -2, 1. The horizontal radius, A equals square root of 4 is 2. And then the vertical radius, B equals 5. Okay, so let's plot our point. Center is -2, 1. A is 2, so that's horizontal, so we want to go left and right. 2, 1, 2. And then we're going to go up and down 5 from the center. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Sure I did that right. And then now just draw your circle. Excuse me, I keep calling circle. I apologize. Draw your ellipse. So again, if I think about it, remember this is 2, okay? And then this way is actually 5. Okay, so it's going to go 5 this way and 2 this way. Okay? So remember that whole length, the horizontal is actually 4, the whole length. Okay, so let's try this next one. So we're going to separate them again with x's and y's. So I have x squared minus 6x. I'll put our y's together. 4y squared plus 24y. And I'm going to go ahead and move 42 over here. So 1 minus 42 is a negative 41. Okay, so let's let's complete the square. So first one, -6 divided by 2 squared is going to give me a 9. So I had 9 over here. This is good. Oh, this one, sorry, we have to pull out a 4 first. Now we can do something with that. So that's going to be a 9 again. But don't forget, it's 4 times 9. So we have 4 times 9. So that means we have to put 36 over here. Okay, so complete the square, quantity squared. So we get x minus 3. Plus, and over here though, we are going to get a 4 times y plus 3 quantity squared equals, so -41.9, actually that comes out to just a 4. So now what we do is this must be 1, the 4 has to go away, so we're going to divide everything by a 4. Remember, please divide everything by 4, not just once, not just where you see. So this is reduced already, so x minus 3 quantity squared over 4. These 4 cancel, so I wind up with just y plus 3 quantity squared equals a 1. Okay, so our center is 3, negative 3a, which is the square root of 4, which is 2, and b, because understood 1, is just 1. So positive 3, 1, 2, 3, out 2, and then up 1. Both ways. It's kind of like a... Okay, so we've been calling the these radiuses horizontal and vertical radiuses with air quotes, I should say. So they actually have names for them. So our first one is the minor axis, okay? The minor axis is actually the shortest length from endpoint to endpoint through the center. Okay, so that for here, this would be this for us. And that's the length, so it's the whole measurement. So for this one, the minor axis for here would be 2, because it's the length, so measure it all the way out. 2 units, we don't know how long it is or anything. So the major axis is actually the longest length. So it's the longest length from end point to end point through the center. Okay, so for this one, it would be up here, this would be this way. So this is 2, this is 2, so the major axis length would be 4. Okay. Now, we have covertices and vertices, okay? So the covertices are the endpoints of the... Sorry, I think my mic went off. The endpoints of the covertices are endpoints of the minor axis. So our endpoint for the minor axis was this one, which would be what? 3, 2. And this one would be 3, not 2, sorry, negative 2, 3, negative 4. Okay. Vertices would be the endpoints of the major axis. So that would be these red ones. This would be a negative 1, negative 3, and then 3, what's this? 3, 4, 5. This one would be 5. Excuse me, that's a positive one. I'm sorry, I'm getting those messed up. Positive 5, and then a negative 1, 2, 3. Apologize. Okay. All right. Okay. Those are hyperbolas.